All right, the next part of this lesson is going to be dealing with the properties of real numbers. So for any real numbers a, b, and c, we have a set of properties. And we're going to be doing this in terms of both addition and multiplication. So the commutative property means that the order of addition doesn't matter. So a plus b is going to give us the same number as b plus a. Same thing with multiplication. So this is telling us that the order of multiplication doesn't matter. So a times b has to be the same thing as b times a. The next one is the associative property. So for addition, what this is doing is it's moving our group. Okay? So here, if we simplify this set of parentheses, so a plus b, and then we add that new number to c, it would be the same thing as adding b plus c first, and then adding it to this number. So again, really this is another way of saying that the order of addition does not matter. Multiplication, same thing. So if we move our grouping symbol around, we're still going to get the same answer. Now the difference between those two properties is that the associative property is dealing with groups of numbers. Okay? The commutative is just dealing with two at a time. Next one, the identity. So identity means that we end up getting the same number again. So we either add or subtract a number to another number, but we get our original number. So for addition, the way we do that, so let's say my a is really 3. So if I add something to it, I want to get 3 again. So the only number that does that in addition is 0. So a plus 0 is a, and again the order of our addition doesn't matter, so we can also say that 0 plus a is also going to be a. So that's the identity. So if we add something to something and we get itself back. Now for multiplication, it's not 0, because if we take 0 times a number we get 0, and that's not what we started with. So for this one it is 1. So let's say that 3 is really my number here. So if I take 3 times 1, I'm going to get 3. And again, the order of our multiplication doesn't matter. Next one is the inverse. So this is undoing something. Okay? So for addition, the opposite of addition is subtraction. Okay? So, and we can always write something as plus a negative. So really we're thinking of it in terms of addition, even though we say subtraction. So if we take a plus its opposite, we are going to end up with 0. And again, the order that you do that in won't matter. Now for multiplication, the inverse, when we undo something, gives us 1. So it always gives us the identity. It's easier for you to think of it that way. So the opposite of multiplication is division. So we would take the reciprocal of whatever this number is, multiply them, and we should end up with 1. And again, the order of that does not matter. All right, next one is the closure property. So this just means that we can take any two numbers in whatever set of numbers that we're working with. So it could be real numbers, it could be rationals, whole numbers, naturals, irrationals. And when we add numbers in that group, we get a number also in that group. So in our case, since we're working with real numbers, we would have to take two real numbers, add them together, and we would end up with a real number. Now, as you start getting into more advanced math, the closure property doesn't always hold, depending on what the rule is for that set of numbers. So that's why we're kind of talking about it now, just to expose you to the possibility of that happening someday in your math career. And the last one is our distributive property. So this is saying that if we take this and we multiply it to both of those groups and we simplify, and again, it doesn't matter what side it's on, when we simplify it, we get the same numbers on each side of our equal sign. Now again, in certain sets of numbers, so we're actually going to see this when we start talking about matrices, this property doesn't always hold. Okay, so we have to be careful. We have to know what set of numbers we're in. Okay. All right, so let's do some examples. So we are just naming the property. So what happens from the left side to the right side? So if we're looking at this, we have 3 plus 4 equal to 4 plus 3. Well, if we are looking at our examples here, that matches our commutative property of addition. Okay, so commutative, so I'm going to abbreviate it, so commutative of addition. All right, next one. So again, if I'm looking at this, we have 3 times 4 in a group times 5. And then it looks like our set of parentheses changed. So if we're looking at that, that matches our associative property of multiplication. So again, I'm going to abbreviate this. So associative of multiplication. And our next one, we're taking 2 times 1/2 equals 1. So we ended up with the identity. And since it's a 1, that means that we're dealing with multiplication. So this is going to be an example of our inverse property of multiplication. So inverse of multiplication. So again, we're just taking what those look like and matching them to the form that's up there in that chart. All right, so here, what is the additive inverse of 6? Okay. Now, if we're dealing with inverses, that means that we need to add something to 6 to get 0. So the additive inverse of 6 will be -6, since we're dealing with addition. All right, next one. What is the multiplicative inverse of 6? Well, if I go again up to my inverse, that means that I'm dealing with 1. So what do we need to multiply times 6 to get 1? Well, the easiest way to do that is we create a fraction. So I'm just going to put this over 1, and then we would flip it over. So 1/6 would be our multiplicative inverse. All right, next step. So it says to simplify, and then to name 2 properties that we use to simplify. So really, we use these properties all the time. We just never name them. So when I'm looking at this, it looks like to simplify, we're going to have to distribute. It looks like we have to do it twice. So I'm going to write that off to the side here. So one of our properties that we're using is the distributive. And there is no addition multiplication with that one. We just call it the distributive property because it's a combination of the two. So let's distribute. So now that will be 12x minus 6y, and then we're distributing a -2, so -6x minus 2y. So when we start combining like terms, really what we're doing is we're rearranging. So I'm saying that this problem right here is really the same as 12x minus 6x, so I'm putting my x's next to each other, and minus 6y minus 2y. So by rearranging, and most of the time we just do this in our heads, we don't even realize it, we're actually applying our commutative property. And that would be of addition. All right, so now if we continue, we would combine our like terms. So this will be 6x and then minus 8y. There's nothing else that we can do to simplify. So that means that this would be our final answer. And we have named our 2 properties. Last example, it says evaluate 2a minus b plus b squared for a equals 7 and b equals 3. And then we're going to classify our answer. So that's going to be from the beginning of the lesson. So let's start with our evaluating. So again, wherever I see an A, we're going to replace it with 7, and B gets replaced with 3. Now I'm going to use parentheses when I'm doing my replacing. So 2 times 7 minus 3 plus 3 squared. So again, we're just going to start simplifying. So 2 times 7 would be 14, minus 3 plus 9. So we multiplied here, and then we did our exponent rule. So now we're adding and subtracting from left to right. So 14 minus 3 is 11, and plus 9. 11 plus 9 is 20. So here's our answer, and then if we're classifying that, well, we know it's a real number. Since it's not in a radical, that means that it has to be rational. And that also is going to make it an integer. And a whole number because it's positive, as well as a natural number. So it's all of them. And that will conclude lesson 2.